What's up, everybody? It's Dan from SageMathTutoring.com. And here I have a homework assignment actually that my student already did, but I am going to do it again upon his request and think out loud through these problems so he can get a better sense of how to do these problems correctly. So what is featured here, well, first of all, it's a geometry class, and as is the case often with geometry classes, they're going to insist that you understand the distance formula and slopes because that will come into play at some point. Now, the distance formula is right here. That is something that eventually you're going to have to memorize, unfortunately. Most students certainly remember the whole big radical thing. It's usually the stuff that's in between that gets a little crazy. You know what I mean? I tend to think of it as a face. Okay, so this might be weird, but that's the part that's easy to remember. Then we have an eye here, a nose, an eye, and the eye is closed. The eye is closed. And you got these weird eyebrows too, so don't forget the eyebrows either. And then X, X, Y, Y. Now, most teachers will present x2 minus x1, y2 minus y1. So that's fine. You can do it that way. Okay. Now, the truth of the matter is, what's kind of cool about the distance formula is that it actually doesn't matter. As long as just the x's are here and you're subtracting one x from another x, and as long as the y's are here and you're subtracting one y from another y, the fact is you're going to be squaring the result, and that's going to pump out a positive result one way or the other. So the good news is you can sort of afford to forget about the 2 and the 1 part, but it's definitely the case that's going to be x minus x here, and it's definitely got to be the case that it's going to be y minus y over there. So that is a brief abstract overview of the distance formula. It looks like the teacher is also emphasizing the slope formula, which is over here. Now, in order to find the slope between 2 points, you're going to want to use this formula. And it is the case that M is a popular letter that math people like to use to represent the slope, which is really weird. It's kind of random. It seems random, at least. There's probably a good explanation for it, but I don't know it. But the truth is that the slope will always be rise over run. So in other words, how much up or down you go goes up top. How much left or right you go goes down below. Rise has to do with up and downness. Run has to do with left and rightness. The rise represents the change in y values, and the run represents the change in x values. And it is the case that the word rise rhymes with wise, which is kind of helpful. All right, so you can remember that. It's the rise goes up top, the run goes down below. The best way to learn how to use these formulas is to use them, okay, to actually use them. So that's what we're going to do. Find the slope and the distance between these 2 points. So they want the slope and the distance. We're going to write the distance as a simplified radical, no decimal answer. So in other words, don't use your calculator. That's code for don't use a calculator. Leave your answer in a radical. Now, they asked for the slope and then the distance, but you know what? They gave us the distance formula first and then the slope formula. So I'm going to find the distance and the slope. It doesn't really matter as long as you provide both. But we're going to start with the distance formula. I'm going to strongly recommend labeling the points x1, y1, x2, y2. We're going to be doing that for all of these, all right? Because in the beginning, that's going to make your life a lot easier, all right? Remember, this is x1, y1, that's x2, y2. Now, some of you might be wondering, could I have called this x1, y1 and this x2, y2? And the answer is yes. It actually doesn't matter which one you call x1, y1. Just go ahead and pick one, call it x1, y1, and then call the other one x2, y2. So we're going to set up the stage. I'm big on setting up the sort of exoskeleton of everything. This is just me. You don't have to do it this way. But I like to just write all that because I know I'm going to be doing it anyway. It's like, why not? You know, I'm going to be drawing it anyway. Might as well draw the structure. Plus, that will sort of prompt me with regards to what the next step is. So what goes here? Well, according to the distance formula, it's x2. What's x2? x2 is 1. So you just plug it in. What goes here? Well, according to the distance formula here, it's x1. What's x1? Well, according to our labeling, x1 is 4. So that goes here. So I think my student at home probably is getting the hang of it already. What goes over here? It's y2. So what's y2? y2 happens to be 3. You see how helpful it is to label the points. If you don't label the points, you could kind of get lost in the process. What goes over here? Well, apparently y1 goes there. What's y1? Well, according to our labeling, it is 7. Okay? So then at that point, what we're really going to do is PEMDAS. Now, PEMDAS, as you may recall, is the order of operations. And the P in PEMDAS basically says, if you have an opportunity to simplify stuff that's inside parentheses, go ahead and do it. So I'll say it again. If you have the opportunity to simplify stuff that's inside parentheses, go ahead and do it right away. Well, we do have the opportunity to simplify stuff that's in parentheses. We have 1 minus 4 in these parentheses. We could totally turn that into a negative 3. Similarly, we have a 3 minus 7. We could totally turn that into a negative 4. So we're going to do that right now. We're going to have a negative 3 inside the parentheses. Don't forget that the exponent of 2 is still there. And then we're going to have negative 4 inside these parentheses. Don't forget that the exponent of 2 is still there. And then at that point, we've satisfied the P and PEMDAS. Now we're going to move on to exponents. And exponents, that says apply the exponent. So we're going to apply that exponent. When we apply the exponent of 2 to negative 3, it becomes 9. And don't forget the plus. When we apply the exponent of 2 here, that's going to be negative 4 times negative 4, which is positive 16. So that is going to become radical, aka square root of 25. Now, what is the square root of 25? The square root of 25 is 5. So that's good to know. All right, nice clean answer. So what we've just learned is that the distance between these 2 points is 5 units. If you were to draw a straight line between these 2 points and measure that line with a ruler, the ruler would read 5 units. Okay. Now we're not done because they also want the slope. Now the slope, once again, is found by using the slope formula right here. So we'll do a little divider here. The slope formula is m equals y2 minus y1, right? y2 minus y1. Well, what is y2? y2, according to our labeling, is 3. So that's going to be 3 minus y1. What's y1? y1, according to the labeling here, is 7. So it's going to be 3 minus 7 all over x2 minus x1. Well, x2 is 1, x1 is 4, so that's going to be 1 minus 4. So the slope is going to equal 3 minus 7, which is negative 4, all over 1 minus 4, which is negative 3. Now that is correct, so we're totally on the right track. However, it is the case that a negative over a negative is a positive. So if we're going to reduce that, or if we're going to simplify it, it's going to be 4 over 3. So what that tells us is this slope between these 2 points is such that it would go up 4 over 3 units, up 4 over 3 units. Okay, that's the slope. So that is how you do these problems here. Okay, now there's only 4 problems, so I say we just barrel through all these. Starting with the distance formula with problem number 2. Guess what I'm going to draw? The exoskeleton. I'm going to draw 2 eyeballs that are closed that have the exponent of 2, which is basically like eyebrows. We're going to have x2 minus x1 here, y2 minus y1 there. So since we're going to be doing it that way, let's label the points x1, y1, x2, y2. So with regards to the first parentheses, again, that's going to be x2 minus x1. So that will be negative 7 minus negative 2. Okay, so we got some negative numbers here, so we will have to be careful soon. This is y2 minus y1. What's y2? y2 is negative 7. y1 is 3, if you look at it. Okay, So now it's getting serious because the teacher has provided us with some negative coordinates, which could make our lives a little bit more complicated, not too much more, but a little bit. So we're going to have to be just careful. We're going to have to be careful. That's all. We're going to make sure our negative and positive addition and subtraction game is on point. So we have a -7 minus a -2. Now, anytime you subtract a negative number, it's really the same thing as adding. So I'm actually going to draw a vertical line so it looks like a big plus sign, okay? Once again, anytime you subtract a negative number, it's the same thing as adding. So we have -7 plus 2. -7 plus 2, hopefully my student understands, would be -5. Now, my student at home, if you have to pause the video to sort of remember that or work through that fact by using scrap paper and looking at it, feel free to do that. But once again, I'll say it. -7 plus 2 is -5. So for my student at home, if we have to review that more, if need be, I'm happy to do that. But your adding and subtracting of negative and positive integers, unfortunately, will have to be totally on point. So we got -5. We got -7 minus 3, okay? Well, you start at a -7, and then you go 3 to the left on the number line, so that's going to give us a -10. So we've done the P and PEMDAS. Now we're moving on to the next part. -5 squared, that's -5 times -5. That is positive 25. Boom. Then we have -10 squared. That's -10 times -10, also known as positive 100. So we're going to have 100. So then we have the square root of 125. Now, here's where I imagine it got a little weird for the students because this is a radical. And, we could say, oh, well, that's the answer. The answer is square root of 125. However, you're going to have to simplify that. Okay, you're going to have to simplify that. Now, let's talk about how to simplify radicals real quick. I'd like my student at home to temporarily forget the problem and focus only on this section here. Let's just remember that 1 squared is 1. 2 squared is 4. I understand my student might be wondering, okay, so what? Well, you're going to see how this relates in a moment. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. Now, I could keep going. 8 squared, well, it's 64. I could keep going, but I think really what's most important, what I'm getting at here, is the fact that it's really these numbers. Let me make sure it's in the screen. Sorry about that. It's really these numbers here that I want to highlight, okay? These numbers here are called perfect squares. And the reason they're called perfect squares is because each of these numbers is the result of squaring another number. Now, I'm going to say that it's really helpful to just kind of be familiar with at least the first few perfect squares. I mean, the next one would be 9 squared, which is 81. So 81 is a perfect square too. But just to be aware of these, at some stage in your math experience, you're going to start to recognize 4 as a perfect square. And anytime you see 16, there's going to be a part of your brain that remembers, oh, 16 also is a perfect square, among other things. Same thing with 36, same thing with 49. Now, you're probably wondering, why am I talking about perfect squares? Well, it turns out that being familiar with perfect squares is a decent way, it's at least one strategy that can help when it comes to simplifying these, okay? Now you're going to see why in a moment. Another concept that's going to be helpful when you're simplifying these is to know how to factor stuff. For example, if I wanted to find all the factors of 125, one thing you could do is what I call the rainbow method, which is to put 1 over here and 125 over here, and then draw a rainbow between them, because you know that 1 times 125 is 125. So if I want to know factors of 125, well, here's 2. 1 happens to be a factor of 125, and 125 happens to be a factor of 125. Then you could ask yourself, does 2 go into 125? Well, it doesn't. Then you could ask yourself, does 3 go into 125? And the answer to that is no. Then you could ask yourself, does 4 go into 125? Well, it doesn't. Then you could ask yourself, does 5 go into 25? Well, yes, it does. So you write 5. And then 5 times what? Well, it turns out that 5 times 25 goes into 125. So we just stumbled upon 2 other factors of 125. And then you could kind of keep going up the line and just checking numbers. Does 6 go into 125? I don't know. Let me see. 125 divided by 6. Apparently 6 does not go into 125. Then you could ask yourself, does 7, does 8, does 9, does 10? So as far as I could tell, these are actually the only factors of 125. Okay? These are the only factors of 125. Now that's going to come in handy because we're going to simplify this, taking advantage of this information and our awareness of perfect squares. The truth of the matter is that 125 could be split, radical 125 could be split as the square root of one of the factors, which is 25, and another factor called 5. Okay, that's kind of an interesting law of square roots, is that you could take factors of this number and then split them apart like that, and then take the square root of these separately. Okay, so it turns out that 25 is a perfect square. So that 25 could be square rooted. Square root of 25 over here, well, that's just 5. So what we're left with is 5 square root of 5. And that is the proper way of answering the question of what is the distance between these 2 points. We used the distance formula, we went through the motions, we got all the way up to the square root of 125, and then we simplified that by splitting it apart into a perfect square factor and a non-perfect square factor. And we did the square root of the perfect square factor, and it turned out to be 5 radical 5. Now that is as far as you can go. Now if you plug that into your calculator, you're going to get some weird decimal, but remember, they said no decimal answers. They said that over here, right? No decimal answers. So that's their way of saying if you have a radical, we want you to simplify it, okay? Now I'm hoping there is going to be more opportunities to practice that, okay? And since there might be more opportunities to practice that, I'm going to leave this list of perfect squares over here. In the meantime, we're going to find the slope between these 2 points here. We're going to find the slope. Now the slope is once again a result of the slope formula. So we're going to go ahead and set up m equals, well, it's going to be y2 minus y1. That's going to be negative 7, which is y2, minus 3, because that's y1. And then down below, it's going to be x2 minus x1, so that's going to be negative 7 minus negative 2. Now, do you see how we have a minus negative? So once again, I'm going to just obnoxiously turn that into a plus symbol. Okay, so we need to remember that. Now that's going to become negative 7 minus 3 is negative 10, and negative 7 plus 2 is negative 5. Now, a negative over a negative is going to be positive, and a 10 over 5 is just 2, or 2 over 1. And we could call it 2, though. Let's just call it 2. So that's actually the slope. That is the slope between these 2 points right here. It's just as simple as labeling them and then religiously relying on that slope formula. Okay, so now we have radical 3, or problem number 3, which is going to be radical exoskeleton land. We're going to call this x1, y1. We're going to call this x2, y2. And it's going to be x2 minus y2 in there. So it's going to be negative 7 minus 5. And then it's going to be y2, which is negative 7, minus 9. Going through the motions, we will get negative 7 minus 5 is going to be negative 12 squared, plus negative 7 minus 9 is going to be negative 16 squared. Now, negative 12 squared is going to be positive 144. Negative 16 squared is going to be positive 256. It turns out that when you add those together, you're going to get 400. All right, so 400. Now, that is something that can also be simplified, because the truth of the matter is 400 is itself a perfect square, okay? So if you think about it, 20 squared gives you 400. So therefore, the square root of 400 is 20. Now let's say that wasn't so obvious. Let's say you had radical 400, or the square root of 400. You could have split it into the square root of 100 times the square root of 4, right? Let's say you wanted to take that and split it apart in the same way that I kind of did over here. Well, the square root of 100, what's that? That's 10. The square root of 4, what is that? 2, right? So that could have also been 10 times 2, which would have given you 20, which, oh, look at that, that's the answer. Okay, so even if you weren't aware that 400 is already a perfect square, then you could have done that trick that we did before, where you just kind of split it into a couple factors, and you got a perfect square factor of 100, perfect square factor of 4. Square root of 100 is 10, square root of 4 is 2, and 10 times 2 is 20, and then you would have had the answer. So your teacher would definitely be happy with that. Now we'll go off to the side over here when it comes to the slope, the slope. So we'll bring it into this section. The slope will be m equals y2 minus y1 up top. So that's going to be negative 7 minus 9 up top. And down below, it's going to be x2 minus x1. So that's going to be negative 7 minus 5. And it turns out that negative 7 minus 9 up top is negative 16. It turns out that negative 7 minus 5 down below is negative 12. Now, first of all, negative over a negative is going to be a positive. So we already know that it's going to be positive over positive ultimately. But it is the case also that not only do these negatives turn into a positive one, but we could also think of the 16 and the 12 sort of reducing. They're both divisible by 4. 16 divided by 4 is 3, and 16 divided by 4, pardon me, is 4, and 12 divided by 4 is 3. So that would sort of reduce and turn into a positive 4 over 3. So that is the slope there. So once again, it was a negative 16 over a negative 12. Negative over a negative is a positive, so you can cross out the negative symbols. 16 and 12 have a common factor of 4. 16 divided by 4 is 4. 12 divided by 4 is 3. And we ended up with 4 over 3, and that's the slope. Okay, so looking at this next one, we'll do a little divider. So problem number 4. Okay, we're going to use the big square root symbol. There it is. Boom. We're going to make sure we label the points. Please do not forget to do that, my dear student at home. Things will get confusing otherwise. I can pretty much guarantee it. So you're going to want to label that and then just go through the motions. Remember, it's going to be, I'll do subtraction as well. It's going to be x2 minus x1. So I think you would agree that's going to be negative 2 minus negative 6. Look at how I'm being very careful. It's minus and negative. I got to have a little space in between there to make sure that I know, my future self knows, that I'm subtracting a negative number there. Next up, it's going to be y2 minus y1. y1 is negative 10. y2 is negative 10. And then we have y1, which is also negative 10. And bringing it down, let's see what we're going to have. It's going to be these square things. -2 minus -6. Remember what I said about subtracting a negative number? It's really the same thing as adding. So anytime you see those two negative things next to each other, you can replace it with an addition symbol. So what belongs here? What's -2 plus 6? Well, that's going to be +4. Done with that part. What's -10 minus -10? Once again, I'm going to turn that into a plus symbol because anytime you subtract a negative number, it's really just adding. What's -10 plus 10? Well, that would be 0. All right, so what do we have? We're going to have 4 squared, which is 16. And we're going to have, what do we have at the end of the day? We have the square root of 16. Well, what is that? That is 4, all right? The square root of 16 is equal to 4, and that is actually the answer. To the distance, that's the distance between these 2 points for sure. So that's good to know. Now, moving on to the slope. They want the slope as well. So the slope formula is going to be m equals y2 minus y1. Well, what's y2? That's -10, so it's going to be -10 minus y1. What's y1? y1 is also -10, so it's going to be -10 minus -10 up top. Now, even for anyone who's worried about this, they're like, what is going on up there? I don't even know. Well, here's the good news. You don't have to know yet what's going on up there. You just put the numbers that belong there. Make sure you're doing the right stuff. Write it down and keep moving. I'm a big fan of keeping moving to stay in the flow, okay? Down here, it's going to be x2 minus x1. What's x2? x2 is -2. It's going to be subtracting something. And then what are we subtracting? We're subtracting x1. What's x1? -6. Now we can worry about what's going on up top and what's going on down below. As far as, simplifying it, we have a minus minus, which is really just a plus, so it's a big plus sign. Similarly, we have a negative negative, so that's really just a plus. And I'll bring it over here. -10 plus 10 is 0. -2 plus 6 is +4. Now, anytime you have a 0 in the numerator and some number in the denominator, that is literally just 0. So it turns out that the slope between these 2 points right here is 0. Now, you might be wondering, is that possible? Well, yeah, you could totally have a slope of 0. It's absolutely possible. It turns out that, a slope of 0 basically means that there is a horizontal line connecting these 2 points. Okay, so the line itself would end up being horizontal. Okay, so that's what the slope of 0 means. So, focusing now on this one, hopefully my student at home is getting the hang of it. Let me label these first. I'm going to say label. Oops, I made a mistake, didn't I? Yeah, it's x1, y1. That's important. So what I did is a big no-no. You don't want to do that. You're going to want to call the first point x1, y1. And you're going to want to call the second point x2, y2. So that's hugely important. Please remember that. So we're going to have this situation. Okay, x2 minus x1 is going to be -3. Let me use a different color. -3 minus -3, right? And then over here, it's going to be y2 minus y1. Well, that's going to be 9 minus 2. All right. So I see that double negative situation, so I'm going to convert that to plus. Now that's a 0 squared, which we're going to worry about later. Then we also have 9 minus 2, which is 7. So that's going to be 7 squared. I'll keep it in parentheses because why not? Now 0 squared is just 0. I think anyone would agree with that. 0 squared is just 0, and I think anyone would also agree that 7 squared is 49. So ultimately, what's left over underneath this square root symbol was just 49. What is the square root of 49? Well, it is 7. Boom. So that's the answer there. Okay. Turns out that it's going to be the square root of a perfect square, and the square root of 49 is 7. Now, in case that's not clear for my student at home, let's say you're having trouble remembering what the square roots are. Well, I don't know, maybe just write down something like this on your scrap paper so that you just have a nice list. 1 squared is 1, 2 squared is 4, blah, blah, blah. And just know that these numbers on the right, they are what we refer to as perfect squares. These are all numbers that are such that if you took the square root of them, you would get a nice number. For example, the square root of 64 would be 8. The square root of 49 would be 7. That's what we just did, right? Okay. So that is the distance between these 2 points here, right here. The distance is 7. So the question now, of course, is what is the slope? Well, the slope is going to be m equals y2 minus y1. So that's going to be 9 minus 2. And it's going to be negative 3 minus negative 3, right? So negative 3 minus negative 3. Looks like we had that double negative, so we're going to immediately convert that to that plus sign, and then we're going to take it from there. So I'm going to write m equals again. 9 minus 2 is 7, so we have a 7 up top. Now, what is negative 3 plus 3? Well, it turns out that is a 0. Now, that is as far as we could take that. However, what your teacher is expecting you to know, and what your teacher is very likely expecting you to say, is that this is what we call undefined. So whenever you have a 0 in the denominator, it's undefined. Now, let's be very clear. You're totally allowed to have a 0 in a numerator, and then when the 0 is in the numerator, it would be 0. But when the 0 is in the denominator, in a way that's kind of not allowed in math land, so we call that undefined. Okay? Now, there's reasons why that is that I don't really want to get into. I'm going to say for my student at home, just remember that. That is something that I'm going to say you should memorize. Anytime you have a 0 in the denominator, that's what we call undefined. Now, what does that mean as far as the line? What does that mean visually with regards to the line that would connect these 2 points? Well, what that means is the line is vertical. The line goes straight up and down. So if you have a line that has an undefined slope, that means it's vertical. Another way of saying it is that all vertical lines have an undefined slope. That's true. If the slope of a line is 0, it's horizontal. You could also say that all horizontal lines have a slope of 0. Okay? That's important. All right, moving on to the next. So I'll do a little divider. Looking at the distance formula. Well, first of all, here's the distance formula. Subtraction is subtraction. We'll call this x1 and y1. x1, y1, and we'll call that x2, y2. So remember, that's x2 minus x1. So that is going to be 1 minus negative 4. And then in the other parentheses, it's going to be y2 minus y1. So that will be negative 10 minus 2. So then over here, it's going to be a double negative. So let's turn that into a plus symbol right now. It's a big plus symbol in there. Well, the question is, what's 1 plus 4? Well, that is 5. So we're going to have 5 squared there, which we're going to worry about later. Then we have a negative 10 minus 2. What is that? Well, that is negative 12. Totally negative 12. And that's going to be squared as well. I say we bring this up a little bit, and we'll do it underneath. So what is that? 5 squared is 25. Negative 12 squared is 144. And we will bring it up here. So 144 plus 25 is 169. And the square root of 169 is 13. Now, let's say you didn't know that. Let's say you didn't know that the square root of 169 is 13. Well, one thing I could say is, we could have kept going with our list of perfect squares. And, maybe the teacher wants you to know more perfect squares than just these. So, for these problems, you might want to just do a little chart where you remind yourself, all right, 9 squared is 81, 10 squared is 100, 11 squared is 121. You could always use a calculator if you feel like you're not sure about that. 12 squared is 144. I think a lot of people actually do have that one memorized. And then we have 13 squared is 169. And then I'll wrap the green box around the perfect squares. So everything that's in the green box is a perfect square. 1, 4, 9, 16, 25, 36, etc., etc. And one of the perfect squares happens to be 169, and the square root of 169 is 13. Square root of 169 is 13. So we're going to embark on the next part of the adventure. The next part of the adventure is to find the slope between these two. Well, find the slope by setting up m equals, well, it will be y2 minus y1, and that is negative 10 minus 2. And it will be down below x2 minus x1, so it's going to be 1 minus negative 4. 1 minus negative 4. Once again, we see that double negative. So I'm going to say, let's go ahead and put a big plus sign right there. On the next line, it will be m equals, what's negative 10 minus 2? Well, that is negative 12. What is 1 plus 4? Well, that is 5. Now, we have a negative over a positive, so that is just negative, okay? You could actually leave this, and this could be the final answer. I feel confident the teacher or the computer system that you're using would accept this, okay? I feel confident that your teacher would accept that. Now, the textbook, if you have a textbook, would be m equals with the negative in front of the dividing line. And then it might look something like that, okay? But make no mistake, these are both saying the same thing. These are two ways of saying the same thing, okay? Now, that's how you do it. That's how you do this stuff. Hopefully that was helpful. That was a lot. That was a good amount. It's a good amount of information, but that's how you do it. Hopefully that was helpful. So for my student at home, you could always slow the video down. You could always rewatch it. You could always speed it up, whatever you have to do to help your learning process. You could also pause it. You could try the problems yourself without my help and then unpause it and see if you are correct. So there's all kinds of things you could do, but it is absolutely vital that you're aware of this process, that you have practiced this process, and you know how to do it. It is very vital that you memorize these two formulas. These are huge. Memorization is not fun. No one likes to do it. But occasionally in math, you're going to have to do it. You want to try to minimize how much you do it, but occasionally you're going to have to do it. And these are definitely things that you should memorize. All right. So I will talk to you all later.